Okay, hello. Today we will be doing a 1.1 to 1.6 pre-calc review practice FRQ. Okay, so in the directions we're given that the function f, which means f of x, is assumed to be a set of all real numbers, no imaginaries. X for which f of x is a real number. Okay. Solutions to equations must be real numbers. Determine the exact value of any expression that can be obtained without a calculator. As we can see at the top here, this is a no calculator FRQ, which is fine, because I'm going to show you today how to find the actual answers. Unless otherwise specified, combined terms using algebraic methods and rules for exponents and logarithmics were applicable. For example, 2x blah 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 should be written in equivalent forms. For each part of the question, show the work that leads to your answers. Okay? Perfect. So let me make this smaller. Okay, the function g and h are given. And this is them. Okay, so find all of the values of x for which g of x equals 0. That means find the zeros. And g of x, we are given. So 4x plus 3. Oh my god. We're going through it. Okay. X equals 4x plus 3. X minus 2. X plus 3. So this is already in factored form. So what we can do to just find the zeros is take out each and put them and set them equal to 0. So for this one, it would be positive 2. X equals positive 2. X equals negative 3. Okay, we have the two zeros. So we can put them in the zeros. So you have negative 3, 2, and then over here. So we can do it over here. 4x plus 3 equals 0. Okay, we subtract the 3. Subtract the 3. So 4x equals negative 3 divided by 4. Divided by 4. X equals negative 3/4. Okay, so now that is one of our zeros as well. And then we set it into our zeros. They're not in least to greatest order, but we know these are our zeros because we know there is 1x, 2x, 3x. We know there's 3 zeros based on the fact that when we multiply and put it into standard form, it'll give us a degree of 3. So this is our answer for this one. Moving on. Find all of the values of x for which h equals the function h of x equals 0. Again, we're looking for zeros, but this time we are given the equation in factored form. So we must solve. x3 minus 2x2 minus 15x. Here, we know we can factor out an x, so then we are left with x to the squared minus 2x minus 15. And then right away, we know x will equal 0. So we already have one of our zeros. Okay, but now we must factor this one out. So negative 15, I'm using the x factor method. It won't always work though. We know 5 and 3 are some factors, but 15 is negative and so is negative 2, which means our 5 will be negative. So then we have x minus 5 and x plus 3. And we set them equal to 0. We come out with x equals positive 5 and x equals negative 3. So there are our zeros. Again, not in order, but this is our answer. Okay, so now moving on to part B. The function k is given by 2x squared minus 11x minus 21. Find all values of x for which the function is greater than 0, which means we want the positive. So what we first have to do is find the zeros. Now this might look scary and all, but it's okay. We're going to rewrite the function 2x2 minus 11x minus 21. Again, we're going to pull out our factored form. 2 times negative 21 is negative 42, negative 11. So now, if you don't know that off the top of your head, come to the side. 1 times 42, 2 times 21, and 3 times 14. Okay? So 14 and 3. And we have a negative 11, negative 42. So we know one of our numbers has to be negative. And in this case, it will be negative 14. So then again, we come down. We have our factored form, 14x plus 3. However, we are not done yet. In the equations before, we didn't have a leading coefficient like we do now. So now we have to bring this leading coefficient back down and divide both equations by it. This one divides perfectly, giving us x minus 7. However, this one doesn't. So we have to shoot it up and create 2x plus 3. So now we can begin. Our 0 for this one is x equals 7, and x equals negative 3. Oh my god, I'm sorry, guys. A negative 3, 2. Okay, so these are our zeros. However, we don't have a calculator, and we cannot find this anywhere else, or at least not yet. So what I'm going to be doing is the line to find which areas are positive. So we know our zeros are 7 and negative 3, 2, which is a mixed fraction. So we know it's actually 1, negative 1, 1/2. So negative 1 and 1/2. So the farthest left will be negative 2. And in the middle, we'll have 0. And after 7, we'll have 8. And then actually what I'm going to do is I'm going to put these at the top so I can show you. They're really like, okay. Okay, so negative 2, 0, and 8. Okay, so now we come back down. We have, this is our main equation. And 2x plus 3. This is before we actually found out our zeros. So now we know we have 3 x's we must plug in. So first, we're going to plug in negative 2. Minus 7, 2, negative 2, plus 3. And then this gives us a negative number. This gives us negative 4 plus 3, which is a negative number. Negative times a negative is equal to a positive. Okay, so we know negative 2 is positive. Okay, now we plug in 0. 0 minus 7. And then we plug in 2, 0 plus 3 is equal to, we know this is, we know this is negative. 0 minus 7 is negative 7. 2 times 0, that cancels out. Plus 3, that's a positive. A negative times a positive is a negative. So we know 0 is below the x-axis. Now we bring 8 down, minus 7, which gives us a positive 1. And then 2 times 8 gives us 16, plus 3 gives us 19. So this is a positive times a positive is a positive. So now we know that our equation is positive from all the way left to negative infinity. So negative infinity to negative 3/2, and then we're going to unite it to 7 infinity, because 8 goes all the way right. So this is our answer right here. Okay, moving on to part C. The function m is a polynomial function of degree 4. So we know our x is 4, which means we'll have 4 zeros. Okay, So we are given our zeros right here. Just cross them out a little. So these are our zeros. We have -1 x and 1 minus 3i. So m of x is equal to x plus 1. And the reason I'm saying plus 1, even though we're giving -1, is because when we set this equal to 0, we're going to do -1 minus 1, which gives us x equals -1. So then we're brought back to the -1. So that's why we have to do that. Okay, so now if we keep going, x minus 6, and then this is where some people get messed up. We know this is a real number, so the opposite of it is -1. And then this is an imaginary number. We are given the negative, so we know there will be a positive 3i. But then i's are just squared negative numbers, so there's still a plus or minus. So our answer is x minus 1 plus 3i, and then x minus 1, again, the -1 does not change. Okay, minus 3i, because we know there's two imaginary zeros. And this is not the standard form, this is the factored form. So now, in order to find the standard form, we must, I forgot the term. We must like keep multiplying like this. You get, yeah. So if we do that real quick, that's x2 minus 6x plus 1x. So that's -5x minus 6 times 1. I mean -6 times 1. Okay, and then we factor this. This is x2. This is minus 1x. Okay, this is where we're gonna slow down a little bit because we need everybody to understand this. So we're gonna do a list. So we know x2 is the greatest we'll get. Okay, so now x times -1 is -x, and then this is like a list. So -3xi. Okay, we're gonna erase the bottom work. I hope you guys got that. And then, yeah, hold on. I'm sorry, guys. Okay. And then we cancel that x, and now we go to -1x, which is just -x again. And then -1 times -1 is +1. And then -1 times -3 is +3. Oh, wrote it in the wrong section. It gets its own section. +3i. Okay? And now we are left with 3ix, +3xi. This cancels out, so that's good because we don't want an imaginary number. -1 times 3i, so that gives us -3i. Boom, that cancels out, which is good because we don't want an imaginary number again. And then -3i times 3i. So this is the same as saying 3i, okay, times -3i. We can separate the real numbers. Or I don't know, like, yeah. -9, and then we have I times I. I times I is saying I squared. And the reason it's imaginary to begin with is because there was a -1. And -1 gives us I and 1. So what we're looking at is an imaginary 1 with a negative number. So when you turn it back, that's what it is. It's a -1. So this equals -1. -9 times -1 is +9. So our number is 9. So now we have to add these two. This is -2x and 10. So then negative 2x plus 10. And now we keep going. So now I'm going to do this right down here. So this is x to the 4th, negative 2x. I'm going to write this down here, negative 2x 3. And then we have positive 10x to the 2nd power. And then we have negative 5 to the x 3rd. And then, so from negative 5 to the x 3rd, we go from negative 5x to negative 2 times negative 2x, which gives us positive 10x squared. And then negative 5x times 10 gives us negative 50x. And then we're given negative 6 times x squared, which is negative 6x squared. And then negative 6 times negative 2x is positive 12x. And then negative 6 times 10 is negative 60. So then, x to the 4th, we add these together. Okay, so 50 plus 12, that is negative 38x. And then here we have 14x squared. And then here we have negative 7x to the 3rd. Okay, so negative 7x to the 3rd. And then plus 14x squared. And then minus 38x. Oh, we're running out of space. Oh my god. Minus 60. And this is our answer, if I did my math correctly. Let's check. Yep. X to the 4th, negative 7x 3rd, plus 14x squared, minus 38x, minus 60. And that is how you do it. Thank you and have a good day.